my lab so I have a courtesy appointment in computer science, and I have a group where all my students, they do a PhD in education and a master's in computer science in AI here at Stanford. So it's a really interesting environment because we can tackle educational problems very deep, but also with very strong kind of computer science chops and skill methods and all of that. And so speaking of that, those are my 3 students who helped me also with the content of this presentation, and they come from very different backgrounds, philosophy, physics, computer science, and they all do research on this interface between AI and education. So let me start talking about an old dream that humanity has, and this dream is very well captured in an illustration of a Parisian illustrator from 1899, which is this one. So this was imagining the school of the future in 1899, in the school in the year 2000. So in the year 2000, the teacher would just grind books in this little machine, and then the students would just get the content in some kind of magical form through those headsets. And so that's how people imagine the school of the future. It's funny that with all this high technology, they had to have a child to turn the thing. They couldn't just put a motor there. It's weird, but in any case, so where is this coming from? So, for centuries, education was something that was just for a very small percentage of us. 95% of people had no access to education, and 5% had access to some elite institutions throughout the centuries. But education was not really like a project for everyone. It was a project for a few people. And then, at some time between, in the last 200 years, we decided that education should be universal and everybody should have access to it, and everybody should have, the same stuff, the same content, the same educational opportunities. And that created like a gigantic problem, I mean, in a good sense, an engineering problem for humanity. It's like, how do we get millions and millions of kids and teach advanced mathematics and science and language and all kinds of things? It's something we've never done before. We've done a lot of teaching and learning for people who were self-selected and were already very capable of doing things, but never like for everybody, for the entire normal distribution of interests, skills, abilities, and all of that. So that's a huge project. And one way we've been constantly thinking about how to do it is this. So it's, let's automate it, because we automate everything else and then it becomes easy, right? So, we automate so many things, and we used to like go and kind of work the land and all of that, and then we invented a tractor, and the machine can do it for us, and then we can do other things. So I mean, we have this template that automation will just save us from all kinds of things that are really huge projects. However, like there are different templates. There are some areas in which it doesn't quite work that well, and I'll talk about that a little bit more. So this is when radio came about. So this was 30 years later. But people are like, radio will be the solution for, because then you don't need teachers anymore, you don't need schools, you just put a radio and people will. And then it was the TV, and also the solution for the teacher shortage. And then, machines. So this is the 2 examples of teaching machines from the 1920s, the Pressey testing machine and the Skinner teaching machine from the 1950s. And then, this magazine report, will robots teach children, and all of that. So this is something that we've been thinking about for a long time. Can we just, automate teaching and make machines do it for us in the same way that machines do a lot of things for us? But unfortunately, this is a project that has consistently failed. So radio as a solution for education failed, TV failed. Those teaching machines also failed, and even more modern instantiations of this, like the something that was called the School of One, that was like a few years ago. It was a big kind of AI type of environment that would personalize learning, also failed. Then it became something called Amplify, which had like, I think it's something like $400 million of funding to deploy hundreds of thousands of tablets with content and AI for millions of kids, and even with infinite funding, it also didn't work. And then things like Coursera and Udacity and all of that, okay, we have this AI people, they will design all kinds of interesting AI software that will personalize learning and make people learn by themselves and follow their own pace and all of that. And that also didn't work. And of course, it's not that it should not be pursued anymore, but we need to understand why it didn't work, and we need to understand if we are doing the right things to fix it, instead of just keep insisting on the exact same idea over and over and over, which just evidence says it doesn't quite work. So what is it that doesn't work that I'm talking about? Is this idea that you can just put the content somewhere and just give people this access to videos or tests or things like that, and that will kind of do the job, right? So why is it the case that it doesn't work? So let's look a little bit about the problems with that approach. So first problem is those are very standardized and individual environments. The context are reduced to what you can measure, and there is a very simple notion of what it means to understand something. So let's kind of unpack a little bit those things. So first of all, to make those kind of systems work, those AI systems work, you have to standardize the content so much that a lot of stuff cannot be taught in that way. Some content cannot be standardized in that way. Also, it privileges a lot individual learning. So it's you in front of the computer trying to get something and try to understand something by watching a video or doing some kind of interactive thing. But research in the cognitive sciences and the learning sciences for the last 30 years, 40 years have shown that a huge part of learning comes from social learning. So you learn from each other, and you learn doing things together, and that's why you see sometimes in school there is a kid who is not very good at math, and then that kid becomes like an investment banker and make billions of dollars. Then you wonder, how did he do it? He was not good at math. Well, but he was good at collecting people's knowledge about math and solving math problems by interacting with people and getting the stuff done. So it's not your own individual knowledge about things. That's not how we operate in the world. We're always doing things socially, and a lot of those environments, they just look at what you know at the moment without interacting with anyone else, and that's a very limited version of learning. And then there is the issue that it's really hard to do AI if you don't do multiple choice tests, because we don't have the AI to recognize open-ended questions or drawings or all kinds of things. So the contexts are reduced to what can be measured with multiple choice tests, and that's another very big limitation. And also there is this simplified notion of what is to understand something, right? So if I answer a question right, does it mean I understood something? And especially if you offer 5 alternatives, what kind of knowledge or what kind of learning process are you incentivizing? So for example, I'll give you 3 examples of people that would probably have failed a lot of multiple choice tests and questions just because they had completely different ways of looking at problems. So if you give like a physics problem to Einstein when he was 18 or something, he was probably like looking at physics in such a different way that he would get the questions wrong. And so most of the most amazing thinkers and scientists and all of that if you were selecting those people and trying to identify scientific talent with multiple choice tests and questions, you would miss those people because they would not think inside that box. But also, there's this idea, if you get the questions right, you get the concept. And that's not quite true, because first, the questions are very limited. You might train yourself to get questions right, but you might never understand the concept. It's a model that's very linear, and sometimes, those things are they're non-linear. So you might answer 5-10 questions right, but there is one question that you answer wrong, and that's the question that's conceptual. But the computer might think, oh, he got 9 out of 10 right. So, those things are not linear. And also it's hard to often transfer to other contexts. So you answer questions when you're doing something on the computer in an AI type system, but there's very little evidence that you can take that knowledge and apply it to something else outside of that context. So that's, the problem I'm talking about here is like the limitations we have in AI today. They limit the kinds of learning environments we can create with AI, and that's a problem. The second problem is like about the nature of artificial intelligence in general. So, the very definition of a lot of artificial intelligence, things like deep learning and all of that, is that things work, but you really don't know why, right? It's still like you train a system to learn something, and it's doing it right 95% of the time, but often you don't know why. And that, that's not a problem if you're doing stuff where no one will get hurt. So, if you're recommending what movie should you watch on Netflix, I mean, if you get a wrong prediction, it's not going to be you're going to be mad at Netflix. I wasted 2 hours in this movie. What's the point of this? But no one gets hurt. But if you think about education, then people can get hurt in a sense that if there was a mistake, you might change the whole life of a person. So that's the point. It's not enough just to diagnose that oh, this kid doesn't know this idea or this concept. You need to know why. And it's the same in medicine. Like you don't have computers making decisions for doctors. The computers support the doctors in making their decisions. So they detect patterns. They look at like X-rays and all kinds of MRIs and all of that. They look at millions and millions of images of some kind of tumor or something like that, and then the doctor is presented with all that information, properly systematized, and then the doctor makes a decision, but not the computer. I mean, you would never, go to a hospital and say, yeah, just press a key and the computer will decide what kind of surgery I need. I mean, you want a person who understands the causality there, right? And the other problem is like, also AI, by its own nature, it pays attention to a goal. So you always try to minimize, to increase accuracy or to minimize a loss function. And the problem is that sometimes, you might be improving students' performance in one thing, but the algorithm might be harming students' performance in something else that's not being measured by the AI system. So, for example, maybe students are getting very good at answering some arithmetic questions or solving simple linear equations, but they start to hate mathematics because they can't do another series of 10 questions on math, or you're starting to generate misconceptions about how you do things, even though they get the question right, but you're not measuring those things. So when you have those AI things running, they are trying to optimize for one goal, and you don't know if behind the scenes there are other things happening that are damaging other metrics that are important for education. So I don't know if you saw this this thing about YouTube that it was on the New York Times that some mothers were posting stuff online saying that this child-friendly channel on YouTube was showing Spider-Man urinating on Elsa, and and Nick Jr. characters in a strip club and all of that, and that was all going through the filters. And I think it's interesting, so the parents were shocked that their kids were seeing like characters in strip clubs and all of that, and then the YouTube person said, oh, this is the needle in the haystack. We really care about this. The video are continually monitored, and we use a lot of machine learning and all of that. But the question, if you know a little bit about AI, you know that those algorithms, they are not perfect, and to be perfect, they need to be trained. So another question that arises, I think, is like, whose kids will train the algorithms so that other kids will have a better. So do you feel comfortable that, let's say, your kids will go to school and will train algorithms to optimize learning systems, even though those algorithms are not really doing a very good job, and they might get stuff that's wrong, and they might not learn something because there was a problem in the algorithm? I mean, are we okay with that? And I think it's, when you think about the election and the whole Facebook, Google, debate on this, for example, in the Las Vegas massacre, I probably know there was some kind of very offensive stuff that, if you search on Google right after the Las Vegas shooting, for like Las Vegas shooting, something like that, Google there was some kind of fake news links pointing to a person who was supposedly the shooter, who was innocent, but some people kind of inserted that into the internet and made sure it got indexed by Google really quickly. So this person was a total innocent, started getting like death threats and all of that because those things got through the algorithms of Google. But I think the interesting, I mean, we know those things are not perfect, but the interesting thing is that when the Silicon Valley companies were asked about this, they said, well, it's the algorithms. I mean, we can't really do anything. And I think that's a really important thing to think about, how, what if there is a kid who goes through like, 5th grade and gets recommended all kinds of wrong things that are not good for them? I mean, and then can the school say, wow, sorry, the algorithm, now your kid will be forever kind of delayed in his or her development and all of that. So, I mean, this is to say that, those kind of dystopian things come true. We're living a dystopian future, because of that, because of those kinds of blind reliance on AI, and there are unintended consequences to a lot of those kinds of things. And also we have to think that people will try to game the system. If they understand the system, they will game the system. That's exactly what happened in the election, right? People figure out how to game the system much faster than the companies could prevent. But I mean, imagine, as an unintended consequence, if you have an algorithm that could, the algorithm is trying to optimize for like how many questions kids get right, but also how much time they stay on the platform, right? Because for some like business reason, you want kids to stay in the platform more. Maybe the algorithm will start saying, well, if I give little bits of if I slow down this kid a little bit on this learning trajectory, he will be here more time, and no one will know that that's even happening. No one will know why. It's just like the algorithm has billions and billions of data points, but it might well happen in the same way that people are saying now that people with some psychological disorders, that the Facebook algorithms are picking on people that are on the verge of like psychological breakdowns, and then they are more prone to buying things. So, I mean, there are all kinds of dystopian things that can happen if we kind of blindly start thinking about AI in education without thinking about those things beforehand. So I think my point there, with this kind of cautionary tale, is that the ethics of AI are so it's underdeveloped. We don't really know how to deal with those things. We don't know if a self-driving car kills a person, who is to blame? Like, is it the company? Is it the person? we don't know when those elections are won or lost because someone kind of pressed the wrong button. Who is to blame? And the same thing will happen to education. I mean, we're not immune to that. So I think it's just a cautionary tale thinking about, when we're thinking about AI for recommending movies, we can play around with stuff, but when it's about kids and about learning, about people, I think those are really important things to see. But on the other hand, there is a success story that I think is possible too. And so that success story starts with looking at what's happening with national curricula in the last 5 or 10 years. So if you look at the new British Columbia national curriculum, they created a new discipline, a new part of the curriculum called Applied Design Skills and Technologies. So this is a part of the curriculum where kids are learning how to build things, how to program computers, how to make all kinds of things, how to design. And the same happens in the next generation science standards in the US. Now in the national standards in the US, it says that students are expected to define problems, generate solutions, building prototypes, optimizing solutions, and all of that. So that is to say that modern national curricula, those curricula are moving towards much more project-based learning, much more design-based learning. So less just standing in a classroom, listening to a teacher recite all the content, and much more hands-on stuff. And why are they doing this? Because people realize that the kinds of jobs or the kind of life that people will have in the future will require those kinds of those kinds of skills. That it's not, all that. It's not about just you get a job and you do the same thing your whole life. There is this. It's now a cliche to say that when kids graduate, the jobs they will take when they are out of college don't even exist, right? So when they get out of high school, the jobs are not even there. So like data scientist, for example, was not a job like 5 years ago, and so on and so forth. So there is a huge need and push towards those kinds of new 21st century skills, so project-based learning, building things, making things, programming, and all of that. So I work in many different countries, and we work in this way with kids. So kids build things like automated irrigation systems in rural Thailand, or they build projects in their science classes, like a guitar. So instead of just listening to music, they actually build a guitar and play their own guitar. So a lot of this stuff is popping up everywhere in every country, like maker spaces, fab labs, and all of that. And this will become a very important part of education. So I want to give an example of how AI can play a different role that's not just like replacing the teacher and teaching, just delivering content, but it's AI applied to understanding how people learn here, right? Because we don't really have, I can't give a multiple choice test to this kid saying, hey, is a guitar, how many strings are in a guitar, or what kind of wood. That's not really what matters. So with my students, my students and I, we've been working on this thing, on new research tools for that. So to assess learning that is complex, that is like in ecologically valid environments. So for example, you might come from companies where you have engineers or professionals that are doing very complex things that they cannot even explain themselves to you. So you go to an engineer, at Sony or Fujitsu or any of the companies represented here, say, oh, can you explain to me how, and he or she will probably not even know how to explain how he thinks, how he finds solutions to problems, because he or she has been doing it for so long that we call it the expert blind spot. They don't even know. So this is not only relevant for kids, it's also relevant for when you're in companies dealing with very high-end experts, because you want to know how they do things, because then you can teach other people, and sometimes they don't even know how they do things. So we created this set of new research tools that we call multimodal learning analytics, And that's, things that you might be familiar with, but things like eye tracking. So when you have people working on a collaborative task, for example, you can have, they can wear these mobile eye trackers, and then you can see, oops. And then you can see how they're collaborating, where they're looking at, if they are really collaborating efficiently. So there is this thing called joint visual attention, which is a measure of efficient collaboration. And you can measure that by measuring if people are looking at the same things when they talk. So the red dots that show up every now and then is when they're talking and looking at the same thing, right? So you can measure collaboration with those tools, if the people are collaborating efficiently. This is a task that students have to build this tower thing, and we use eye tracking to see how they're doing it, how they reason about it, how many times they build a tower, how they revise it, and all of that. So this is stuff that you could never do without those tools. And also things like we build these systems where you can track the objects that kids or students are moving around. So this is a circuit building activity that we built, and there's a camera with some special algorithms that's tracking what kids do, what students do. And then you can look not only at the final result of what they do, but you can look at how, for example, now this is wrong, so I need to add another resistor, or I need to take this out and put something else. And so you can see all the cycles of problem solving step by step. And that's a much more richer data set to understand what they're doing. And we also use this kind of interesting camera and depth camera technologies like the Microsoft Kinect to try to locate people in a creative environment and see, for example, who are the ambassadors of good ideas. Who are the people that are working together, how they're working together, and all of that. So I mean, this is just examples of how those tools when used with AI, they can provide a lot of interesting insight into what people are doing, not by having them answer a multiple choice test, but by letting them do their stuff, and you collect all this data to understand how they. So let me give you one example. This is about maker expertise. So this is can you build mechanisms, and can you build things can you fix things efficiently, and all of that. And I did it with two of my students. So this particular task that I will just quickly talk about is assembling this gearbox, right? So you have these parts, they have little magnetic things, and then you have to assemble into a gearbox. So we did a study with novices and experts, and then to compare how they did. So this is some of the novices trying to assemble it, just for you to have a good idea, an idea of how it is. But then we looked at this. What they were doing, and my student came up with this coding scheme that looked almost like second by second what students were doing, right? The actual little actions, so putting this gear here, mashing gears, turning an axle. So, and then he kind of coded these videos almost second by second. And then we took the sequences of actions and we fed them into a clustering algorithm to see if we could tell apart experts and novices just by looking at what they do, not even knowing if they're experts and novices. Right? And then, lo and behold, this clustering came out like very nicely in two groups. One group was almost all the novices, one group was almost all the experts. So without knowing who they were, if they were experts or novices, we could separate people just based on the actions they did. And then when we looked at what they did, so this is, the group on the top is the expert group, and the bottom is the novice. And we call them affordance aware and affordance blind. Because we realized that what defined, if you're an expert or not, is not how many years you were working on, in a company or whatever. It was or how many years you were in engineering school, but it was if you understand the affordances of the different parts. So understanding that gears have to connect to other gears, and they have to connect, orthogonally, or so. If you understand the affordances, then you show up in the expert group. So we understood that even not knowing anything about the participants, we understood one marker of expertise. So to be a good builder, a good engineer in that context, you needed to understand the affordances of the materials, of the parts, right? So that's something that now we know, so now we can teach it to other kids. But what happened is that, when we look at the actual different clusters, it's quite interesting to see that the experts, the affordance aware, they do almost twice as many rotations, when they're assembling. Meshing gears, almost like 10 times more. So they understand the affordances of gears because they put gears and they mesh them. They try to see if they fit. So they understand. Mounting axles, almost like 10 times more. So they also understand the affordances of axles. And then interesting, like incorrectly connecting the magnets, the little parts. Each part had a magnet, so it made it a bit easier to connect. So this kind of trial and error thing of just putting things together and trying. So that was, almost 4 times more frequent in the novice group. But anyway, so I think what I'm showing here is that you can use AI and clustering algorithms and these kinds of methods to understand what is about the experts or the good people that are doing a job in your companies or in your organizations. What is about them that makes them perform well, right? And sometimes it's not a test because, as I said, the expert blind spot. You ask people, how did you do that? They don't know, right? So this can kind of uncover those markers of expertise and help you understand what makes people really good at what they do. And then we also did a second part of this study, which is still ongoing, where we use gesture tracking to try to automate a little bit the data collection. So you see that, in this zoomed out thing, that we can automatically collect their posture data. And now we're working at correlating this gesture posture data with other results. So here you see the 2 groups of novices and experts, and we can generate these interesting videos that show the different behaviors of the groups. And one of the findings that we are looking at in this data is that the experts, they seem to pause 3 times as much as the novices. So you would expect that experts would be like doing stuff all the time, right? They never stop. They're just doing. But actually, people who are doing stuff all the time are the novices. The experts, they pause 3 times as much, and then our hypothesis is that they build things and then they stop and evaluate what they did, and then they decide the next step. And then they go into another cycle of building and evaluation and all of that. And that's a very productive behavior, instead of just like trying all kinds of things and being busy all the time. So again, that's something you can use AI or use these kinds of methods to find out another important aspect of the expert behavior that you want other people to learn. So if people are doing problem solving and they never stop to reflect and to take stock on what they did, that's something you can add to your training programs or to your professional development programs, so that you teach people to behave in those ways. So let me go to the third part of this presentation with some recommendations and some hopefully not too pessimistic views of the future. So I think one thing is not placing AI at the center of pedagogical practice, not using it for summative assessment, and being aware that the algorithms are optimizing for a very specific thing, and you might be missing many other things that are important. So you might be picking on content knowledge in a particular math thing, but motivation, engagement, preparation for future learning, all kinds of other things might be missed. So important to leave space for human interpretation, just like in the medicine example I gave. You want the doctor to have access to a lot of data and very deep well-structured data, but the doctor is the person who interprets that. So living space for human interpretation. And I think another important thing is that education should be about debiasing. So you should make sure that everyone has the same opportunities regardless of where they come from and all of that. And as we painfully have learned over the past year or so, algorithms, they promote a lot. They can promote biases because sometimes the programmers are not even aware of their own biases. Sometimes they reinforce slight biases that are present in the data set and all of that. So that's another thing to pay attention to. So the point here is not that AI is bad or you should not do, but people in a position of power that will make decisions, they need to be aware of the limitations of AI so they can make good decisions. And it should help the decision makers, not make the decisions for them. Just think about, again, the doctor example. Like, you don't want to go to a hospital where there are no doctors making decisions, right? So the same should be for education. And there is this kind of naive idea that AI is smarter than humans, and we see a lot of that in this kind of Silicon Valley press. I mean, if you read the newspapers and blogs and all of that, it's like, oh, humans are so stupid, but AI, we have this kind of interesting fascination for robots and superhuman brains and all of that, and it's fed by this kind of mythology of the Silicon Valley, that the super brain at Google or whatever. So we should understand what they mean when they say super brain. They say, oh, we have a really fast computer running really fancy statistical algorithms, but that's what it is. It's not a real brain actually doing all those kind of things. And I think especially AI is a tool in the toolbox. It's not a toolbox itself. So it's to help us design better things, measure better things, but it's not the thing itself. And so I think another important thing thinking about AI is that there's no iPod miracle. So by iPod miracle, I mean, we used to have to go to the store and buy a CD and all those things, and then the iPod just made that so much cheaper and magically more efficient, right? You just download the music. All that manufacturing of stuff just goes away. So there is no such thing in AI. Just look at Facebook has now 20,000 moderators of content. So it's not you go on Facebook, you say, oh, this is all AI. There are 20,000 people working there moderating the content and training the algorithms, right? So that's something important to keep in mind. So imagine, like, if you're building AI systems for education, you need to think that a lot of what we call AI is just people on the other end training the algorithms for us. So AI systems are good in some limited skills and contexts. For example, when it's about declarative knowledge, when it's about learning procedures, learning routines, math skills, spell and grammar. I mean, there are lots of things that AI are very good for, and I think also good audiences for that. So adults, professionals, graduate students, programmers. So those are audiences that are more autonomous and can manage their own learning much better. So those are better audiences for AI. But I think one important thing is like understanding the content topics that are good, the audiences that are good. It's really crucial for us to design better systems, because the worst thing is that you're designing for an audience that cannot consume that product, content that's too complex for the AI we have today. So that's the kind of thing the kind of place you don't want to go. And AI systems are also very good for research on learning, as I said, provided we have access to what's going on. So I showed you some example of how AI can reveal hidden markers of expertise that would not otherwise be available. I think it's important, you come here because you want to see beyond the buzzwords and the kind of, mythology and all of that. So, people use all kinds of like personalized learning and at your own pace, fun learning. Everything is fun, is effortless. So it's important to look at what people are actually doing, like what is the content they're actually doing. And I think for that it's really important to have productive and equal partnerships between education researchers, practitioners, AI researchers, and that's exactly what MediaX is about promoting those kinds of research. And just to wrap up, I think this is an important thing, is that perhaps we don't even know what the most productive applications of AI are. We're like kind of obsessed with this classroom metaphor that it's about teaching, it's about delivering content, but maybe it will be something completely different, that, you know, maybe to start in this room here, or maybe in a coffee break. But I just would encourage you to think about outside of the box of the classroom. So education is not just about teaching and transmitting knowledge. It's about a lot of other things. It's about managing discovery, for example. So when you have people in your organizations that are inventing things, how can you use AI to help them discover stuff, to accelerate invention, to help them collaborate more, right? Maybe AI can help people talk about things and accelerate discovery and invention and innovation. So there are lots of ways to think about AI that's not just teaching the stuff that we already know. And with that, I will end and go to the Q&A. Thank you very much.